Hello everyone, in this video I'm going to explain what the binary is. Modern day computers use electricity to work, and inside of microchip electricity is turned either on or off, which is represented by the symbols 1 and 0. This is called binary. There are 10 counting symbols that we use for all of our numbers. Starting from 0, we count all the way up to 9. Before we run out of the symbols at this point, we can make a lot of symbols, and that would get out of hand very quickly. Can you imagine having to memorize a specific symbol for every single number? That's ridiculous. And that's why we reuse the same symbols over and over again in a very clever system called positional notation. As soon as we get to 10 or an exponent of 10, we need to add another digit to the left of our current digit or digits. Because there are 10 symbols, each new digit has to have a value 10 times greater than the digit to its right. So that's using 10 symbols. But what if you have only 2 symbols to work? Well, then everything that I said still applies with just 2 symbols. Each new digit needs to have a value 2 times greater than the digit to its right. So a sequence like this would be 0, and this sequence like this would be 1, and the sequence like this would be 2, and the sequence like this would be 3. And as you can see, with 3 digits beside each other, we can explain only 0 up to 7. That's all. Now I will show you how to convert a number from base 10 to binary. For example, if I want to convert 13 in base 10 to binary, it's very simple. Just by dividing 13 by 2, and we can write the quotient, which is 6, the beneath of the 13, as you can see, and the remainder I would be right at at the first of this column. And sequentially, the next step would be dividing 6 by 2, which the quotient would be 3, and the remainder would be 0. And for next step, by dividing 3 by 2, the quotient would be 1, and the remainder would be 1. And this finally, we will continue this process until our quotient would be 0. And at this time, because our quotient became 0, we finish the procedure. And by writing from down to up, the remainder down to up converted to left to right, which means 1 1 0 1 1 1 0 1. In the binary, this number in binary also in base 2, which means 13 in base 10 or decimal. Okay, and for converting from the vice versa, which means converting from binary to decimal, the process would be, as you can see, for example, 1101 in binary is equal 1 times 2 power 2 0 plus 0 times power 2 power 1 plus 1 times 2 power 2 plus 1 times 2 power 3, which by simplification, as you can see, it means 1 plus 0 plus 4 plus 8, which means 13.